Okay, so we've already looked at the range. We did that last week. What is the range? Remind me. Don't say the driving range. Gabe. That's right, buddy. That's right. Yeah, so it's all the dependent values or the y values. Okay, so it's the set of dependent elements. Okay. Or the y values. We already. Oh, sorry. That goes on the bottom line. Sorry. Okay. So that's a range, and the domain will be the independent elements. Okay. Good luck fitting that in there. Okay. So, with a series of points, okay, the domain it's a fancy bracket.
That's a bracket?
Yes.
It looks like a D.
Everyone has one. Look, everyone has one on their laptop.
Oh, it's like the...
The squigglies.
Yeah, but that doesn't... Okay.
What do you mean? It doesn't what?
The first one looks like an S and a 2.
Oh, well, that could help you practice. Listen, as soon as you try and draw one, you're going to learn that it's not the easiest thing to draw. So be very careful with your criticism.
Okay, ready?
It is an S and 2 in one direction.
Okay, that one was because I was pressured, but I'm actually...
Not easy. Not easy. Okay. And then the range.
Does it matter how bad our drawing is?
No. It's not a drawing. It's just a bracket.
I can't.
Take it easy, Mozart. Oh, Mozart's yeah. Picasso. Better well done.
What is this?
No, it matters if it's that bad. You can't even tell that's a squiggly bracket.
Well, I don't know what they
I don't know what those are.
Well,
It looks horrible. So, it'll take me a computer science test.
Okay. So, the definition says the domain is the set of independent elements, right? The x values. So for those 4 points,
what's better? Why did you do a loop?
can you two sit beside each other? It's like you're 5 years old. Giggling over a bracket. So it's just the x values. -2, -1, 0, 1. That's the possibilities for the x values. Okay? And then the range, just the y values. Okay? So -5, 10, 15, and 20. Okay? Any questions of that? It's pretty straightforward. Okay? It's just the domain and range is all it's doing is it's telling the person who's looking at the graph, or like if it's describing the function, what the possibilities are in which the function exists. Okay, on what values of x does the function exist, what values of y does the function exist. That's all it is. Okay. With a series of points like that, it's straightforward because there's nothing in between there. It's just those points. So you can break those into their x and y values as the domain and range. Now for the second one, for the domain, you do not need to rewrite duplicates of an entry. Okay, so 0, 1, and 2 are the possibilities for the domain. Okay, and the range can take on the values of -1, 1, 2, and that's it, actually. -1, 1, and 2. Are we okay so far? Those ones are not. You like seeing questions like that because that's free marks. The ones that are not free are the ones that are actual functions. They're a little bit more subtle.
It's like a triple 3.
Okay, so C C is pretty much it's the same question as A and B because it's just a series of points that are on a graph, a grid. So you're just listing the possible values of X and the possible values of Y. Okay? So the domain here is -2. Oops, let me start with the bracket. We got -2, 0, 1, and 3. You tell me if you agree. Okay, so ABC, relatively straightforward. We haven't hit anything too crazy yet, I don't think, okay? It's just mapping, like, possible entries, right? Now, as people are wrapping that up, can you tell me the difference between something like question C and question D now? Dylan?
Question C is like just points right on like coordinates, and then D is not.
Yeah, so what's,
Like you have to find the points on D.
well, it's not so much about finding the points as much as it is about like how many points can you find on D? How many points are on D?
Like infinite.
There's an infinite number of points, right? Like I could plot an infinite number of points in question D, right? So how do you represent that is the question, because that's no longer like C. Can everyone appreciate that?
Can you just do an infinite?
Not quite. Well, kind of. That is actually one style, which I think you'll do in advanced functions. They move away from this kind of style of mapping the domain range. But for now, we have a fancy way, and the textbook has a fancy way. Okay, and what I'm going to do, again, it's important for you to remember that the domain range is just describing what the possible entries are. Okay? The challenge is with question D and question E and F and H, there's an infinite number of points in there. So the way we represent this is a little bit different. Okay, so the best way that I've found to like get your head around that, the domain is going to be the X values. We've already discussed that. So what I like to do with these graphs is I like drawing, like kind of a lower boundary on the grid. Like I know the X values do not go anywhere below that red line. Would everyone agree?
Yeah.
They also do not go above that red line. That's a fact, right? So what we're going to say is, and I'll write this down, just copy this for a second, then I'll write what the variables mean, okay? So it's still, you're going to open that squiggly bracket. You're going to say, I'm going to say the words. You listen to the words. I'll write it down so that you can repeat it back, or like as you do questions, you can kind of put it together for yourself. So it says X. Why is it X? Because X is in the domain. It says X, this fancy letter here. It's a Greek letter. Epsilon. Epsilon.
Backwards 3.
It's a backwards 3. That's all it is. Okay. It says X is a part of. That's what that backwards 3 means. Is a part of. Okay. And then this one, this you've seen before in grade 9. Do we know what that means? You've seen it. You've seen it because I do it with my grade 9s. You've seen it before.
Read it.
Is it real numbers? So it's an R with 2 bars on it. Okay? The capital R with 2 bars on the left side. Okay, so it says now, X is a part of the real numbers. Conceptualize, like, that's okay? Okay, all we're saying, because we said there's an infinite number of points in there. Right, so it's a part of the real numbers. Yeah?
What does the R mean?
Real numbers. Real numbers, yeah. So no imaginary
What
stuff.
does the backwards thing mean?
Is a part. I'll write all this down in a set. Okay, so that you can repeat it to yourself. Okay. Are we okay? X is a part of the real numbers, such that. I'll write this down. Don't worry. I'll write it down. Just copy it down. I'm just saying the words as we put it down on the page. Okay. Now here comes. So this part, for the most part, is the same every single time you do these questions. You should just be like, when you write the domain range, you're gonna write X as a part of the real numbers, such that something. Okay. This is pretty consistent across all the questions, as long as it's a function.
Is
Or-
the line part of the equation, or did you just do that?
The line is a part of the question, such that. Okay, so this is a big long sentence that you don't want to have to write every single time we do one of these questions, right? Which is why they've abbreviated into these Greek letters. Okay, now here's the point of the question. You have to tell me on the right half of that line such that where all of this is true. So what are the entries that make X a part of the real numbers true for this particular function, which is a circle? Specifically a circle with a radius of 3, Bryce.
-3 is less than or equal to x, which is less than or equal to 3.
Okay, so everyone agree that the values cannot go below -3, and they do not go above -3, or +3, sorry. So it has to stay within those red lines, okay? This part, despite my best efforts to tell you to do it this way all the time, kids do it in different ways. I always write the low end of the boundary, -3. Okay, we say the way we read this, and if you do it this way, it's the same every single time. You write the lower boundary on the left, the upper boundary on the right. You stand in the middle, and you read from the middle outward. Sorry, they're just like greater than, well, they both appear to be less than, but you're going to read from the middle. I'll clean it up, sorry. Okay. You can pretty much, every time you do one of these questions with the domain, you can pretty much do this. And then put your numbers in. Okay, and I'll show you how to read this. Okay, so we're going to stand at the X, and then we're going to read sideways in either direction. So it says, X is greater than or equal to -3. Would everyone agree? Okay, but it's also less than or equal to +3. You see, you stand in the middle and read outwards on your boundaries. Are we good?
Yeah.
No. It's not bad. Okay, I'll do the range and then I'll put into words what those symbols mean so that you don't forget them. Okay, what do you think the range looks like? I'll do the range in blue. So again, it is the same thing because it's a circle. Okay, but don't write X as a part of the real numbers for the range because that's not what we're talking about, right? So again, just to highlight, I like drawing these bars. If this helps you, it helps you. Okay, I write the lower, or I identify the lower and upper boundaries for my graph. That'll be the blue. Okay, and it could be different for every question. Okay, so the range here is just going to be y is a part of the real numbers such that y is greater than or equal to -3. Y is less than or equal to +3. Okay, the back of that lesson's blank, so when you're done that, maybe turn over. I'll write in words what all this stuff means, the variables, and Greek letters. Is everybody okay? I can turn the page over. Scroll down. So, X. Yes, sorry. It is. Sorry, I'll be more neat. Sorry. Lots of questions on the penmanship today. And then your conditions. Okay, so you get I think it's fair to not want to write that every time you do a domain range question, right? So just write we just got 4 symbols to help you condense that down into something that's a little bit quicker to write. So it says if you're dealing with the domain, then X is X, the epsilon is a part of, and then you've got the real number symbol, and then such that. And then everything after that is just a condition specific to each question that I give you, or that you see. Is that okay?
To see if it was enough string.
All right. Maybe take a picture of that, or finish copying it, or we okay? It's recorded too. You watch it. Okay. This graph. Let's try and represent this graph with the domain range, right? Like when someone gives you the domain range of a particular graph, you can kind of get an idea of what it looks like on a grid just by reading what its boundaries are. Okay, so for this one, I'm just gonna tack on a couple arrowheads on that. Okay, just to switch it up a tiny bit. So let's try and represent the domain here. Can you draw those red boundary lines, like on the circle, for this particular question? For the W one. For the W looking graph. Can you draw red vertical lines to like kind of contain the graph? No. So what's true about that graph then? In the direction of positive infinity in the x and negative infinity, are there any values of x that graph is not going to take on?
No.
No. So it just takes on all values of x. So your domain for this particular graph, quite easy. It's just, sorry, that was a bad bracket. What do you mean, so was that? That one's not too great. These are hard to draw. You'll find out. Get lots of practice. Okay, no restrictions. So you don't need that such that line. It's just x is a part of the real numbers. Easy. Right, because it can take on any value of x from negative infinity to positive infinity. Yes.
Is there a time when it wouldn't be a part of the real numbers?
No imaginary stuff for your purposes.
No, but like ever. Like, what's the point of drawing it, like of writing that if they're all part of the real numbers?
There are a couple spots. There's one question I think in your homework where it doesn't take on one value in the middle. You'll see. There's one question I think. Bryce?
What do you do when there's holes in the ground?
As long as there's not a, we call those piecewise functions. So if there's a hole in the graph or the graph is like broken, you'd have to write 2 separate domains, I think. You know what I mean? So I think you'd say like the domain, it's x is a part of the real numbers on this range, and then it's also a part of this range. It does not include where the break is. Does that make sense?
How do you like write it that it doesn't?
It'd be 2 separate domains, I think. Yeah. Okay, are we okay? Let's do the range. Not the best question for the range, but we can get a good idea. Oh, I forgot. Yes, people didn't remind me. Okay, it can definitely take on all values of y. What's the exception though?
Underneath.
Yeah, it can't, what's, like, I don't know what you want to call that, 1.75? I don't know. 1.5.
Negative.
Negative. Sorry, yeah.
I got you, don't worry.
Oh, thanks. Won't let me fall, eh?
Okay.
Okay. So it can take on all values of y as long as such that y is greater than or equal to negative 1.5 or whatever it is. Doesn't really
I
matter.
thought,
But
and no, you don't read from the middle because there's no.
yeah, there's no middle here, right? So this one doesn't really matter either way. You could flip this around. All that matters is that the alligator's eating the y. Because it's got to be bigger, right? Y has to be bigger than that value. So you could also write okay, that would also be acceptable. Are we okay? Okay, domain. Oh, hello.
Can you hand that up for me later? She's in here. Yes.
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 I haven't seen her yet, so I don't know what she looks like. She's on my list. Has been since last week.
Really?
Yeah.
Yeah.
Where's Hadley? Oh, there she is. There you go.
Hi, Hadley.
I figured that's probably who it was. I hadn't seen her yet.
How are you taking your phone? Hey,
I've been doing
guys.
attendance. Yes, I've been doing it.
Hi.
Okay. Domain. Where's the lower? What do you think it is?
Under and over.
Under and over? What do you mean?
Oh wait. Never mind. Wait, can you draw the?
Yeah, okay. Yeah, so you can always, I find that the line helps, right? Draw the line, right? Where is that line? What value of x is that line on, Bryce? -3. We know that the graph does not go below -3, so that must mean that the domain, it still takes on all values of x, if I put the arrowheads on, right? Such that x this time has to be greater than or equal to -3.
I've just been drawing threes, I think.
Okay, range. Ask, are there any blue lines that I can draw on this graph?
No.
No. So what's the range?
Infinite.
Dylan?
Y is part of the real numbers.
Y is a part of the real numbers. Very good.
Dylan.
No such that.
Wait, what's the? Stop.
Okay. Let's do H and then we'll come back to G. Okay. Domain. Any restrictions? Any red vertical lines you can draw?
Bracket. No, not really. What is that?
Not really. So it can take on all values of x. Okay. And then the range. What's the range? Could take on all values of y as long as
1 and 0.
they're greater than 0. Greater than equal to? Greater than equal to.
I'm gonna be greater than and not equal to. I forget.
Is that supposed to be a D or is that a O? It's a D. Okay.
Yes. For domain. I'll fix it. Very particular.
That's not even being particular. That just looks like an O.
Well, I mean, there's a pattern on the page, is there not?
Maybe
Wouldn't just randomly write an O now. Okay. This is a lot like these map for whatever reason. Even to this day, these make me think a little bit, but then they're not that bad. So when I write the domain range for G, right? What is that? It's just a mapping of points. It's a fancy way of just mapping points, right? So I'm just going to write the domain. What are the possible x values?
Negative 1, 1.
1, 2, and 4. And the range is 1, 2, 3, and 4.
Oh yeah, yeah.
Okay, the difference now, okay? Irregardless if you were in the pre-IB 10 math or just the regular grade 10 math and you're seeing this for the first time, irregardless, you should all have the skill set to be able to look at all three of those equations that are at the bottom and have some sort of visualization as to where they are and what they look like.
What?
So let's start with the first one. We discussed this already the other day. What graph is the first one? Owen? It's a line, right? It has a y-intercept of 3 and a slope of 2. Does a line have any restrictions? In x or y? Everyone in agreement? So when I put an equation like this on the page and you recognize that it's a line, as long as it is not f of x, how would you represent that? As long as it's not a vertical line, then we have no restrictions. So the domain range for these questions are quite easy because I can say, okay, a line has no restrictions in either direction, x or y. So we just write x as a part of the real numbers and we write y is a part of the real numbers. Okay, the second one you have also seen in grade 10, regardless of which class you were in. Okay, so this requires a little bit of visualization. Okay, and that will, if you can't do that right now, hopefully that comes back as we start to work through what we're going to work through in the next 3-4 days, 5 days this week. Okay, first of all, what graph is that in B? RJ?
It's a parabola facing downwards.
Okay, good. So it's a quadratic or a parabola that's been reflected in the x-axis, so it's now opening down. Okay, and then what happened to it? Gabe? Yeah, it got vertically translated up 3 units. Which means if I were to sketch this out quickly, it would look something, and this is an expectation that you were able to look at this and figure that out, right? That's a grade 10 question. The parabola is upside down and up 3, something like this. Everyone agree? So as a quick sketch, that helps you identify or what the domain range could be. So with a quadratic, are there any restrictions on the domain for a quadratic? No. It doesn't matter if it's facing up or down. Those arms are going to go on forever in either of those two directions, up or down in the y. But for sure, you can plug in you can substitute any value of x and get out a y. Doesn't matter from negative infinity to positive infinity. Everyone agree? I'm going to get some unique y. So the domain is going to be x is a part of the real numbers. What about the range though? Okay, but you need to on a test, so you draw yourself a little sketch for the question. Okay. Bryce?
Y is a part of the real numbers such that 3 is greater than or equal to y.
Y has to be less than or equal to 0?
3.
3. Okay, that's because the graph had been moved up 3 units. Okay, what graph is the last one? Ricky?
It's just another parabola.
That's just another parabola. The difference is this time, it's had more stuff done to it. That's probably the hardest question. It's in the family of hardest questions that you would have done in grade 10. Okay, this year we're gonna add, there's 4 transformations there. There's been a reflection, a vertical stretch, a horizontal translation, and a vertical translation. That's 4 transformations, okay? This year we're gonna mix in horizontal reflections and horizontal stretches and compressions. So that's to be 6 transformations in there. Okay? It's the exact same work you did in grade 10. We're just gonna put in 2 more, and then we're good. In addition to, we're not only going to transform parabolas this year, we're gonna transform 5 other graphs that you're gonna be responsible for. That's what we're gonna start today. Okay? So it's a parabola. If you know it's a parabola, what's true about its domain? Take that free mark. If you recognize that it's a parabola, what's true about the domain? Gabe?
It doesn't have any limit.
Yeah, it just goes on forever in the x direction, right? And so we just, every time you see a quadratic, I'm getting worse and worse at drawing these today. Holy smokes. Look at that. It's 4 attempts. There we go. Okay, but what about its range? It's important to think about what's happened to the graph. What happened? It got reflected, then vertically stretched. That doesn't really affect the range. It just got big. It just got taller and skinnier. And then we moved it to the left 1 and up 6. So what do you think the range is? If it's opening down and it's been moved up 6, RJ?
That y is equal to the real number as long as it is smaller or equal to 6.
Yeah, as long as what is smaller or equal to?
Y.
Y specifically. Okay. As long as y is less than or equal to positive 6. That's it.